Okay, next I want to prove B, part B. And this looks suspiciously similar to the divergence equation, right? The divergence theorem, sorry. And again, if I write it out, it's f dot ds is equal to the triple integral over the whole region of divergence of f, right? What's missing here is, okay, let me even write the normal vector down to see the similarity. Look how similar this one is to that. And look how similar the right-hand side is to this right-hand side. What's missing? The dots are missing, the dot products. Okay, so actually here it's the gradient. And here, this thing inside is the divergence. Okay, so the divergence theorem is what I wrote down here. This is the divergence theorem. Oh, don't confuse divergence theorem with the divergence operator. Okay, this is the divergence operator. But we're going to use this to prove part B. Okay? So first of all, let's assume that our normal vector n is going to be represented as n dot ei times ei. What is this? This is just an orthogonal projection using our vectors ei, where ei is 0 everywhere except 1 on the ith component. Okay, so this is just vector notation, but really I wrote this as many dimensions, but right now we're only dealing with 3 dimensions, right? Okay, so let's start with the left-hand side. We have P. I think P means pressure here. Anyway, that's not important. We have P times N. Okay? And I think X right here represents X, the point X. Okay, but anyway, it's just notation, so it's not important. Okay, and using this vector, using the orthogonal decomposition of n, I get P times the summation of n dot ei times ei ds, if you want. And by linearity, we're going to get, okay, also, I think we need to notice that n dot ei times ei, okay, let's talk about what this is. Let's pretend like n is a vector n1, n2, and n3. So what happens if I dot it with ei, maybe 0, 1, 0, e2? If I dot these two together, then I'll get n2, right? And if I multiply n2 by e2, then this will just be 0, n2, 0. Okay, so actually I'm decomposing n into its coordinates. Okay, what if I multiplied p here? Then all I'm gonna get is I'm just gonna get p right here. And so p is just a scalar, so my p can appear right there, right? But that just means that my n2 is also a scalar. It can come outside, right? And now 0p0 is going to be, maybe I can write it like this. 0, 1, 0 times n2p, right? Because again, p is a scalar. And I can write this as, what is n2 again? It was n dot e2, right? So maybe I should use a different color. I mean, this part's easy, so I don't know if I'm spending too much time on this. N dot e2 and then p. Okay, so generally I'm going to change e2 with ei. Okay, and I'm going to change this part right here. So this is just, by linearity, I'm going to take sigma out, and I'm going to have the double integral of ei multiplied by n dot ei times p. Okay, all of this ds. And of course I can bring the ei out, the vector ei. This is just outside because our summation is over I. Okay, now I'm going to rewrite the inside here as p multiplied by ei. Okay, so it's really n dot producted with ei times p. Now I can use the divergence theorem. Okay, where can I use it on? I can use it on, okay, let me try and get this right. Okay, I couldn't get this right. Let me erase this. And let's move this over here. I'm going to use the divergence theorem on this part, on the red part. Right? Now I can use the divergence theorem because now this is a vector and this is a dot product, right? And therefore, this is going to be equal to the region of the divergence of p times ei, right? And our summation stays the same. Okay, but what is p times ei? Let's pretend like e is 1, okay? ei is e1. Then I'll have p0, 0. What's the divergence of this? That's just going to be dp dx, right? Plus nothing. Okay, now I'm gonna move the summation back in, and I'll have the divergence of p0, 0, the divergence of 0p0, and the divergence of 0, 0p, all of it added together. So what do I get? I get dp dy, dp dz. Okay, once I move the summation inside. Then that's just the divergence, right? By definition of divergence of p. Oh, did I switch notation from dr to dx? From dx to dr? Yeah, it looks like I did. But it really doesn't matter whether you notate your coordinates using x or r. It really doesn't matter. Anyway, this is how you solve part B.